Good afternoon, everyone. My name is Vikshit, and today we are going to do OS assignment. So we are going to explain parent and child process. So now my friend Manoj will share the program. So this is the parent code. So from line number 1 to 4, these headers are included for necessary functionality. Windows.h for specific for Windows specific like API, like shared memory and process creation. Studio.h for standard input output functions like printf and fprintf. stdlib.h for memory allocation and random number generation. String.h for string manipulation functions. Limit.h for constant like int and max. Fifth line defines the size of main array. Sixth to seventh line defines the number of child process. Defines the size of each child's array segment. Line number 8 declares a global variable I for loop iteration. 10 to 11 declares the prototypes for helper functions. Line number 14 allocates memory for main array. Line number 15 to 18 checks if memory allocation failed. If so, prints an error and exits. Line number 20 fills the main array with random integers. Line number 24 to 30 creates a shared memory object to share data between processes. Invalid handle and invalid handle value indicates no physical file is being mapped. Page read write allows read and write access. Array dash size star size of int declares the total memory size. Line number 31 to 34 checks if the shared memory creation failed. If so, prints an error and frees main array and exits. Line number 36 to 42 maps the shared memory object to the address space of the process. If it fails, cleans up and exits. Line number 44 copies the contents of the main array into shared array. Line number 46 to 50 arrays to store process and startups into for startup info for each child. cmd.args holds the command line arguments for child process. Line number 51 to 62 loops to create num-children process. Each child is passed the start index and size of its array segment as arguments. Child process starts each child process using the children.exe. Now my friend Abhishek Gowda Patil will continue the next part.
Hello, myself Abhishek Gowda. I am continuing from the line 63 to 64. Line number 63 to 64 handles errors if child the process fails to launch. Line number 60 to 72 waits for all child process to finish and clean up for their handles. Line number 74 calls the helper function to merge the shorted segments from the shared memory. Line number 77 to 81 unmaps the shared memory, closes the shared memory handle, frees the main array, prints success message. Line number 84 to 87 generates the random integer between 0 and 999 for the array. Uh, Line number 90 to 109 performs a k-way merge of sorted segments into single sorted array. Uses indices to track position in each segment, finds the minimum element from all segments and places it in temp array. Uh, con- uh, it's continued by the presentation.
Hello, myself is Pritam Prasad Seth. Here I explain line by line explanation of our code. Line 1 to 3. This line includes the required header files. Windows.h provides functions and definitions for Windows specific operations such as shared memory. stdio.h provide input output functionalities like fprintf and stderr. stdlib.h includes utility functions such as ADI, OI, and QSORT. Line 5 to 6 declares two functions prototype a sort array, a function that sort an array of integers, compare a comparator function used by qsort to compare two elements. Line 8 the main function is the entire point of a program. It takes two argument C, number of command lines, argument B, array of argument as string. Line 9 to 12 checks if the user provided exactly two arguments in the addition to the program name. If not, prints an error message to stderr and exists with a status code of 1. Line 14 to 15 converts the command line argument v1 and argument v2 string to integers using ATOI start index of the array section to be sorted, array size, number of elements in the section to sort. Line 17 to 20 opens a handle to an existing shared memory object named local shared memory. Open file mapping allows the program to access shared memory file map all access. Grants read write access to the memory. If shared memory cannot be opened, prints an error with the system error code and exit. Line 22 to 25 maps the shared memory object into the program address space map view of file, returns a pointer to the shared memory. If mapping fails, it prints an error, close the file handles and exits. Line 27 to 28 calls sort array to sort the position of the array starting at the start index with the array size elements. The address of the subarray is passed to the function. Next will be explained by Manoj M.
Myself, Manoj, I am going to explain the remaining lines of the code. From line number 30 to 32, cleans up the shared memory unmap view profile, unmaps the shared memory from the program's address space, close the handle to the shared memory object. In line number 34, indicates successful programming terminations. In line number 37 to 39, defines the sort array functions. Uses qsort to sort the array in the ascending order. Parameters array pointer the array to be sorted, size number of elements in the array, size of specifies the size of each element, comparator functions to determine sorting order. From line number 41 to 45 defines the compare functions for qsort, compare two integers, returns a positive value if a is greater than b, 0 if a is equal to b, and a is negative value if a is less than b. So the next execution will be explained by Vikshit M. Shetty.
So the execution of parent code is like this. The output shows that the program attempts to create 10 child process to sort segments of an array, but all attempts fail with error code 2, meaning the system cannot find the children.exe executable at the specified location. Despite these failures, the program prints sorting completed successfully, indicating that the process continues without handling the missing executable error properly. The issue is likely due to an incorrect path or absence of children.exe. Now the output of child.c. The program sorts a specific section of an array sorted in shared memory. Successful case, it modifies the shared memory by sorting the specified range. For example, if your memory has 83572 and you sort indices 1 to 3, it becomes 83572 errors. If the shared memory isn't accessible, it prints an error. Invalid indices or sizes can cause crashes or unexpected results. So that's all for our assignment. Thank you.